What's going on? Welcome back. In today's video, we're gonna start buffer overflow preparation, which is part of the offensive security pathway. This buffer overflow preparation is a room that's comprised of 2 to 10 tasks, from 2 until 11. Every task, as you can see, has different objective, and the general objective is to prepare you for the buffer overflow. So basically, we have them labeled overflow 1, 2, 3, 4, 5, 6, 7, 8. In every case, we need to exploit the buffer overflow exploit. So the first thing to do, we're going to have to deploy the machine and connect to the machine with remote desktop servers. You're going to type this command in your Kali box here, okay? And once you're connected, you'll see the Windows 7 professional screen here, and you can start practicing. So in the first example here, we're going to be doing overflow 1. Now for overflow 1, there is here the material that you need to do the challenge. The material is comprised of the fuzzing script and the exploit 1. Although these scripts can be used for other purposes, right, for testing other binaries, but we're going to use them for this scenario. And yep, so let's get started. And as all of you know, the objective of buffer overflow is to manipulate the behavior of the vulnerable application in order to connect back to us. So in this example, we're going to use immunity debugger. Normally in Linux, we use GDB. In the last videos, we used GDB to demonstrate buffer overflow. Now, for the sake of this scenario, we're going to use immunity debugger. So we open the immunity debugger, and then the next step is to open the vulnerable application that you want to test. File, open, and the application will find it in the OSCP directory in desktop. So I open the application here, and you will see the window open. As you can see on the left, we have the assembly code, instructions, and here we have the registers, and we have down there the memory addresses, the extam, and here we have command area. So how to start? So basically, we're going to first need to execute the application, know how it works, understand how we're going to exploit that application. So basically, we're going to say run, as you can see here, this button, run the program. Now, after running the program, right, we should see a command prompt here. As you can see, the command opened. It means that the application has opened and it's saying listening on port 1337, waiting for a client connection. So the client, so the program that we are testing now, is kind of a listener that takes string of commands from the client that connects to it. So basically, we're going to head back to the machine here, open a new tab, and say nc duplicate specify the IP, and the port that's listening on is 1337. So it's saying welcome to OSCP vulnerable server, enter help for help. And these are the available commands. So basically, we are in overflow 1, and he will specify a string value. For example, overflow 1, and the example will be test, for example. We see overflow 1 complete. Now, the objective here, guys, is to crash the application. Now we know how the app works. Now the next, we want to crash the application, right? We want to provide a number of strings here that exceeds the allowed buffer in the overflow 1. Now, for the purpose of that, we're going to have to generate a pattern. So before that, we're going to configure the Mona directory here, the Mona working directory. Mona script is a script that's used with immunity debugger to facilitate the testing. So first, we're going to set the Mona directory. We can find these commands in the TryHackMe room. So like that. And now we set the directory, as you can see. Okay. So the next thing we're going to generate a payload or a pattern, right? So to generate a pattern, or before generating the pattern, actually, we're going to need to fuzz. Want to know how many characters are required to crash the application. So we're going to head back to TryHackMe here and take the script. So the script here, this is a fuzzing script. I'm going to take it and explain how it works. Fuzzer UI. So basically, this script connects. You're going to have to modify the IP address right up here. The IP address is the IP of the machine that we are testing. The port is the port that the program is listening on. And here we have the buffer, the counter. This script will connect, as you can see here, to the application on the listening port 337, right? And send a number of strings, or number of strings that is increasing by value, as you can see from the while loop here. Every time the string increases in terms of the number. So basically, until we crash the application. So we're gonna click save, hit save, and we run the string. Before doing that, we're gonna need to restart here. So Control F12. Let me see if I can send this to the. Okay, let me click on restart. All right. So basically, we restarted the app, and now it's saying paused. We're gonna say run. Now it's running. Now let's fire the fuzzer. So say, oh, give it permission. Run it. As you can see, the bytes are being sent, and if you see on the application display here, we see that this is the output. Now, the application is still able to handle all of the bytes we are sending, but at some point it's going to crash, and we're going to see at how many bytes the application has crashed, and based on that number of bytes, we're going to create the pattern. So as you can see, it stopped at 2000 bytes, which means that the application has crashed at 2000 bytes, right? Now, the next step is creating a pattern, right, with a number of bytes that is over 2000 bytes, right, in order to see how the instruction pointer here. So actually, we want to see the instruction pointer here. As you can see, the instruction pointer now is written with A's because the fuzzer here sends A's, okay? Now, the instruction pointer is overwritten with A's, right? And as you can see here, the stack pointer points to A's as well. This is the address here. So basically, we want to generate a pattern with exactly more than 2000 bytes, okay? And find the offset at which the crash has happened. So we can specify a customized number of strings or a customized string to see how it's going to appear on the instruction pointer. Now, next step here, let's generate a pattern with MSF or pattern create. So sudo user share exploit framework. All right, tools, exploit, and then pattern create. All right, dash L, and we will specify 2400, for example. So these are the number of characters. We're going to need to copy that number, or we're going to need to copy these characters all right? And these are the characters that we would like to send now, okay? Now, to send this number of characters to the application, we're going to need to copy the exploit code. So basically here, this is the fuzzer, and here is the exploit code. So we're going to place these characters or the pattern we generated in the payload section here. So copy that. And here say sudo exploit py. The IP is right. So here is the payload. Okay, we're going to replace that with the payload here. So copy that, go up. So the payload is ready. Now the next, we're going to need to find the offset, all right? So the offset at which the crash has happened, so we can, after that offset, place the extra number of strings. So here we type Mona find MSB distance 2400. 2400 is the length of the the pattern we have just generated. And we're going to look for the line where it's saying examining registers. So examining register, here's EIP contains normal pattern, offset 1978. So this is the offset, guys, right? We're going to need, oh, actually, I missed myself. Oh, so this is the offset here, 1978. We're going to need that number, okay? So we know where to specify. So we get back to the exploit, nano exploit, or sudo nano. My user is limited. And here in the offset, instead of 0, it will be 1978. We hit save, and we restart the app. Let me do it like that. And then open, paused, hit run. Now we're going to have to send the exploit or send the payload one more time. So say Python exploit py. Okay, now let's look at the value of the instruction pointer here. As you can see, it has changed to 41306.141. And if you look at the ESP pointer, this is the string, as you can see. So basically now, instead of 8s, right, it has been overwritten with these string of characters, right, which is here at the EIP. That means, guys, we have just overwritten the instruction pointer with a customized string of characters, which is this one, right? Instead of all A's. Now we know where to write our own exploit. Okay, now the next stage is writing or creating a payload, right? In the payload, we're gonna use MSFVenom and then send the payload that we have just created with MSFVenom with the exploit py here script. So here the instruction pointer will be overwritten with our own payload. But before doing that comes an important stage, which is eliminating the bad characters. Eliminating the bad characters is a very important stage, since bad characters sometimes they miss the execution of the payload, right, in the memory. So we're going to need to eliminate the bad characters. So for doing that, with Immunity Debugger, we're going to have to generate first a string of bad characters, accepting the null byte, and then we replace the exploit here, payload. Now, so we're going to replace that with bad characters, right? And compare with Mona how the bad characters would appear in the memory. So we eliminate them one by one. So for that, there is another script here. This script is used to generate the bad characters. So let's generate a string of bad characters. Bad char UI. Now run this script. Now this is a string of bad characters. Let's take it and head back to the exploit. Now here comes this portion. We're gonna remove the payload here. Okay, so let me open that with another editor, with like mousepad. So this is the payload. So here we have the exploit. We're going to remove the payload here and replace it with the bad characters we have just generated. Hit save, provide the password. Let me hit save one more time. Okay, now we are ready to send the bad characters. But before sending the bad characters, we got to know what is the purpose of this process. Let's get back here. Okay, so once we send the bad characters, the instruction pointer here will be overwritten with bad characters. Okay, now we want to eliminate them. So in order to eliminate them, we have to compare the bad characters we have just created and which are about to be sent, right, to another list. So generate another list now with Mona, and we execute the null byte. So as you can see, the bad characters have been generated at this path, Mona OSCP byte.txt. That's fine. That's okay. Now let's minimize that and restart everything. Say restart. And here run the app. Now it's listening. Let's get back to the console here. Clear. All right, now let's run the exploit. This time, the exploit will send the bad characters. Okay, hit send. Okay, let's examine the instruction pointer. So the ESP now, as you can see, is overwritten with what seems to be, guys, the address for bad characters. So what we're gonna do now, we're gonna have to compare. Okay, this address now contains the bad characters at the stack pointer here. So we're gonna have to use Mona now to compare the what is in this address here at the stack pointer. Okay, so the byte array we have just generated with Mona. Right, so let's see here. So it's saying we have 00 and 01 as bad characters, which is weird. There must be more. Now let's see the comparison. Oh, just a second. Okay, so here the command. Now I have to specify the instruction pointer. The stack pointer here is saying 01, 01, 8, 9. So show me how many bad characters we have. Oh, that's now correct. So we have the bad characters here, 0007. Now how it got this result? So basically, if you remember, we have generated this file, byte array. It contains a byte array of bad characters, right? And at the same time, we have just sent the bad characters to the program. So here it's saying the comparison, okay, between what is in the stack, all right, from the payload, and compare them to what is in the byte array. So it's saying in the stack there is this number of bad characters that match, right, the bad characters in the byte array. So here is the part where we have to eliminate these bad characters one by one. So first we have the 00, No. Let's make sure these. Okay. Right. So what's next? We have the 07 and 08, 2E, 2F, A0, A1. Of course, don't forget the double quotes. Now we're gonna hit enter. All right, let's go now to the exploit and remove the same bad characters from here. So 0007, 08, and 08, 2E, 2F, A0, A1. Look for A0, A1. Okay, here they are. Now save. As I said earlier, the goal here is to not see these bad characters in the comparison so that they don't exist in the stack anymore. So say here, no, say restart, run. Okay, and back here, the same, we're gonna have to do the comparison. The address is a stack pointer address 018C. FA30. So it's saying here unmodified, which is what we wanted. So this means that no bad characters exist in the memory anymore. Okay, so now after we get unmodified, no bad characters, we're gonna have to select a location from the memory where bad characters don't exist. Okay, so we're gonna have to use a command like that here in the command area. Oh, trying to copy it. Okay, and we put the bad characters. So basically the bad characters are here. And say here, yep, and hit enter. So here we're gonna have to see an address. Where is Mona? Okay, so we can select one of these addresses, right? We can select this one or this one or this one and put that into return address. So say I want to select the first one, okay, this one. So I get back to the exploit here and update the return. So instead of P's, we put this address and make sure to inverse the characters. Okay, the inversion is because this is little Indian, so we have to do the inversion. Don't write them as they are. Means that don't write them as 6250. You have to do an inversion. So how to do that? Remove this. Okay. All right, and let's copy the diagonal line. Get back here. Okay, so where do we start? So we start like that, AF, and then we have 11, then 50, and 62. I guess no, I'm not correct here. So the inversion starts this way. So 62 as you can see here, or AF comes first. No, I'm correct. I was correct actually. So X, so here, XAF, and then comes the 11. These things should be done carefully. X50, or you will have to repeat the all of work all over. And then 6.2. Okay, now save the payload. Okay, now next generate the MSFVenom. So clear. So here we exclude the bad characters from the payload. So we get back here, copy the rest of bad characters, and remove them or exclude them while creating the payload. And say enter. That's good. Copy the values or the buff value. Get back here, remove this old one, and paste the buff, right? And then say payload equal EUF. Okay, now the padding here, we have the padding. The padding value will be NOP, no operation, so that we allow for more space, or we give more space on the memory for the execution of our payload. That's the purpose of the NOP. So say here, copy one, x90, and times 16. Save that. Now you are ready to send the payload and receive the reversal. So here one more time. Restart. And send the payload. And we receive the reverse shell. So that's how it worked. ID, or who am I? OSP POF preparation. Now we can do privilege escalation, but we're not meant to do that on this video, since this is only explanation of the buffer overflow. So I hope you enjoyed that. And next, we're going to do all of the tasks for buffer overflow, so you won't feel any doubts why you were doing it. Thanks for watching.